Okay, this video is for section 3.1 of the notes, and it's the idea of absolute extrema versus relative extrema. So looking at this graph, if I just, without giving you any calculus information, if I just said, hey, on this graph, what would you say is the absolute maximum value? And I'm going to put on here, absolute maximum value. Well, you look at the graph, it looks like the highest point on there is probably right here, right, when the y value is 5. And so what we would say is we'd say the maximum value is 5. Now, we could say that it occurs at x equals, we'll say 1, but the actual maximum value is 5. And so I could say, well, what's the absolute minimum value? Well, when you look at this graph, what is the lowest point on the curve? And there's a problem because at first we're looking right here, right? That looks like the lowest spot, but there's a hole there. So then you might say, okay, well, it's right before you get there. Well, okay, what number is that? So it's kind of hard to tell, you know, what that is, because if you say that that hole is at y equals -4, then what would be the next point where you actually have a point? Would it be -3.9? And if you say yes, then I could say, well, what about -3.99? And if you say, okay, that's it, I could say, well, what about -3.999? So let's just kind of leave that blank, and we're going to say, you know, we can't really tell what the absolute min is. Now, in pre-calculus, you did some things with relative max and relative min, and so it's kind of like it sounds. Relative means what's the maximum point relative to its area. So like, for example, it looks like if you look at this point, that is a relative min, because relative to the little section that it occurs, did I say min? I meant max. It's a relative max. So you might say, well, there's a relative maximum value at, I'm just going to estimate and say 2.2. Now again, you could say that the relative maximum value occurs at x equals -4, but the actual maximum value might be 2.2. We might say, well, what about this one up here? Well, yeah, that's a relative maximum, so maybe there's a relative maximum at 5, relative maximum value. Whoops, I put that in the wrong place, 5. Or a relative min, you might say, well, this point right here looks like a relative min. That might be at, what, -1. And this one right here could be a relative min, because relative to its little area, it's a minimum point. So maybe, what would that be, 1.7? I don't know. Okay, so that's just kind of the idea of relative versus absolute. All right, so now let's bring in some actual calculus vocabulary. So first of all, we need to look at this term called critical numbers. Okay, so critical numbers occur when the derivative equals 0 or the derivative is undefined. And we're going to use that critical number concept a lot in chapter 3. We're going to use this for a lot of other things, but there could be AP questions that just simply say, what are all critical numbers? Now, what does it look like on a graph? Well, if you look at the graph that's up here, we've talked about how, because that would be a horizontal tangent line, that right there the derivative would be 0. And we could say the same thing right here, the derivative would be 0. And we could say the same thing here, the derivative would be 0. And what about right here? Well, it's not a horizontal tangent line, because remember how we talked about if there's a sharp turn, that means the derivative is undefined. So if we're saying, hey, what do they look like on a graph? I'll say, well, if the derivative is 0, it's like a smooth max or min, right? A smooth curve. Whereas if the derivative is undefined, it's like a sharp turn, right? And it might be a max or a min. That's not the issue, but it's the fact that it's a sharp turn as opposed to a smooth curve. Okay? So absolute extrema. Well, this is going to sound kind of silly to say that the description is the highest, right, would be the maximum. And I hesitate to say this because I don't like to use the same definition I don't like to use the word we're defining in its definition, but I want to say it is the absolute highest value, or it is the absolute lowest value, meaning there's not multiple ones. So the highest is the max, and the lowest, obviously, is the absolute minimum. And so does every function have an absolute, and you all understand that extrema is just the plural for max and min. So does every function have an absolute max and an absolute min? Well, the one we looked at up here, we were able to come up with the absolute max, but we were not able to come up with the absolute min because of the idea that there was a hole there. So what the extreme value tells us is, the extreme value theorem says that you're guaranteed an absolute max and min if you have a closed interval. If you have a closed interval. And by closed interval, that means you include the endpoints. Include the endpoints. So the one that I have up above was not a closed interval because we did not include the endpoints. But if I changed it, if I went up to the top and I said, okay, that's not a hole, that's going to be a solid dot, and that's not a hole, that's going to be a solid dot. Now you're guaranteed an absolute max and an absolute min. Okay, and yes, it's a theorem, but we don't usually refer to that as the theorem. We just know that you're guaranteed an absolute max and an absolute min if you have a closed interval. Now, where do the absolute max and min occur? Well, on this graph, the absolute max was the same as the relative max, right? That's where the derivative was 0. But the absolute min, assuming we include the endpoints, was not one of the relative max or mins. The absolute min was the endpoint. So we're going to say they occur at critical numbers or endpoints. So absolute max and min could either be at a critical number or it could be at the endpoint. So here are the guidelines, and this is what the homework for today is going to look like. Here are the guidelines for finding absolute extrema. Okay, so guidelines for finding absolute extrema. So number 1, find all critical numbers. I'm just going to say CN. Find all critical numbers. And remember, critical numbers are when the derivative is 0 or derivative is undefined. So you start by setting the derivative equal to 0. See when the derivative is 0. See when the derivative is undefined. Okay. So after you find your critical numbers and your endpoints, then step 2 is evaluate. Now I'm going to say f of x, and I just mean the original function. So evaluate the original function at those critical numbers and endpoints. And then step 3 is, and this seems like a kind of a dumb thing to put as, step 1, step 2, step 3, but often I see people do 1 and 2, and then they never actually label their answer. So step 3 is label which one is your absolute max and which one is your absolute min. Okay, so you really need to follow this process to make sure on a free response you get full credit. And these absolute extrema, they'll be both in multiple choice, and they're also going to show up in free response. One year they showed up like twice in the free response questions, which is a lot for one topic. Okay, so look at my example. Find the absolute extrema, so that means both the absolute max and min, of this function on a closed interval. So since they said absolute, that means they had to give me a closed interval. So we're going to start by step 1, find the critical numbers. So I need to find the derivative. So the derivative is, bring down your 1/5, x to the negative 4/5 minus 1. And yes, I want to find when this is 0 and when it's undefined. But if I think of this as 1 over x to the 4/5 minus 1, it might be the easiest thing to do. And I know on this one it's not that big of a deal, but it might be easiest if whenever you have a derivative that has a fraction, to think of it as one big fraction. So if I, think about getting a common denominator, right? So I'll multiply both the top and the bottom by x to the 4/5. So if I get a common denominator, really I've got here 1 minus x to the 4/5 over x to the 4/5. Okay, well, so I'm going to say critical numbers are when that derivative equals 0, right? Well, remember how we said a fraction can only equal 0 if the numerator is 0. So the critical numbers are going to be whenever 1 minus x to the 4/5 is 0. So that would be when the derivative is 0. Or what would make the derivative be undefined? Well, wouldn't that be if the denominator is 0? So, or if x to the 4/5 equals 0. Okay, so the first part is finding when the derivative is 0. The second part is finding when the derivative is undefined. Well, this one is easy to solve. This is going to be when x equals 0, right? This one is easy to solve because x to the 4/5 would have to equal 1. And I know this is kind of a basic one to say, but let's say it weren't so easy. If you wanted to get rid of 4/5, wouldn't you raise both sides to the 5/4? But if I raise 1 to any power, isn't the answer just 1? So there are two critical numbers. Critical number, critical number. So there's my step 1. Found both my critical numbers. Now step 2, I need to evaluate the original function at those critical numbers. So I'm going to evaluate the original function at 1. I'm going to evaluate the original function at 0. But I also want to evaluate the original function at the endpoints. So at -1 and at 32. Okay, so if I plug 1 into the original function, just looking right here, wouldn't that just be 5 minus 1 is 4? And if I plug in 0, I get 0. If I plug in -1, well, the fifth root of -1 is -1. So times 5 would be -5 minus -1. So that comes out to be -4. And then if I plug in 32, well, the fifth root of 32 is 2. Times 5 is 10. Minus 32 is -22. So now think about these as ordered pairs, right? What's the highest y value? Well, isn't the highest y value going to be right over here at 4? So we would say the absolute max value is 4 and occurs at x equals 1. It's important to not only say what the maximum value is, but also where it occurs, because sometimes they'll ask what is the maximum value, and sometimes they'll ask where does it occur, and you want to be careful that you know, if they ask for one, that you don't just automatically give the other one. So if you give both, you're always going to be safe. Okay, so there's my max. Now, what's the lowest y value? Well, wouldn't the lowest y value be right here at -22? So we could say the absolute min value is -22, and it occurs at x equals 32. So I've found the absolute max and the absolute min. Okay, look at my next example. Ooh, trig, we love trig. So for my next example, whoops, sorry. Okay, on this one, we have trig involved, but I'm going to still do the same thing. So I'm going to start by finding all critical numbers. So my derivative, let's see, the derivative of secant is secant tangent. Okay, so I'm only looking on this interval from -π/6 to π/3. So first of all, what would make this equal 0? Well, I'll say here critical numbers. When? Well, since there are two factors, if either one of those factors is 0, then I would have a critical number, right? Well, secant is never going to be 0, and I know that quickly and easily because I remember the graph of secant. Remember, it wasn't like these alternating kind of parabola things? Well, notice they never equal 0. So there aren't any zeros for secant, but tangent does equal 0. Isn't tangent going to be 0 at 0, pi, 2 pi, 3 pi, blah, blah, blah? So the only one on this interval would be x equals 0. Okay, but also, don't we have critical numbers when the derivative is undefined? And so again, if either of those factors is undefined, then the whole thing is undefined. Well, don't both secant and tangent have asymptotes at those half pi marks? Remember how the tangent, you know, doesn't it do this kind of thing and it keeps repeating? Well, remember right here between those pieces you had your asymptotes, right? Same thing for the secant. So tangent and secant are both undefined at pi/2, but that's not in my interval. So since neither pi over 2 or negative pi over 2 are in the interval, I don't have to worry about those critical numbers. Okay, so step 2, evaluate the original function at the endpoints, so negative pi over 6 and pi over 3, but also at the critical number, right? So f of 0. Okay, so I'm going to plug pi over 6 into the original, so secant of negative pi over 6. This would be secant of 0. This would be secant of pi over 3. All right. Well, secant, I don't have secant on my chart, so I'm going to think of this instead as the reciprocal of cosine, right? So I'll think of it as 1 over cosine. All right, so forget the negative. What is the cosine of pi over 6? Well, on my chart, I know that the cosine of pi over 6 is square root of 3 over 2. Now, what does that negative mean? It doesn't mean that you necessarily make your answer negative. It means the angle is negative, right? Well, if I go in the negative direction, I'm down here in the 4th quadrant. And in the 4th quadrant, is the cosine positive or negative? Well, 4th quadrant, cosine is positive. So that's just a positive 1 over square root of 3 over 2. So that comes out to be 2 over square root of 3. Okay, so again, think of this as 1 over the cosine of 0. Well, the cosine of 0 is 1. So 1 over 1 is just 1. And then think of this as 1 over the cosine of pi over 3. So 1 over, well, the cosine of pi over 3 is 1/2. So isn't that going to come out to be 2? So again, I found my critical numbers right here. I evaluated them in the original function, and so now I need to label, well, what's the highest value? You're like, well, I don't know what 2 over square root of 3 is. No, but I do know that the square root of 3 is definitely just a little bit less than 2, right? And so 2 over something a little bit less than 2 is going to be just a little bit more than 1. So it's definitely not as much as 2. So I'm going to say absolute max value is 2 and occurs at x equals pi over 3. Okay, and then, like I said, this is kind of like 2 over 1.7-ish. But again, I know that it's 2 over something that's less than 2. So this is definitely going to be just a little bit more than 1, which means my lowest is right here. So I could say absolute min value is 1 and occurs at x equals 0. Okay, so those are the steps for finding absolute max and min. Even though we mentioned relative max and min, for the homework tonight, you're not actually finding them. We'll do that later on. Okay, so hope that helps.